How are you, my friends? This is lecture 23 of the pre-calculus course, double-angle formulas. Let's start directly to derive sine of 2x. Sine of 2x is equal to 2 times sine of x times cosine of x. We get that from the lecture 21, where we have the formula sine of u plus v, if you remember. Sine u cosine v plus cosine u sine v. We can apply this to sine of 2x, which we can write as sine x plus x. Just apply here the u is the x and also v is the x. So it will be sine of x cosine of x plus cosine of x sine of x. We can add these two because the product here is commutative. So this is the same value, 2 sine x cosine x. So to find sine of double angle, we need sine of the angle itself, cosine of the angle, multiply them, multiply by 2. Now on this slide, I put all the formulas needed for double angle. So there is formula number 1, sine of 2x, we mentioned that. Cosine of 2x, we have 3 formulas. I will call them 2, 3, and 4. And I will explain more about that in the next slide. So let's just read it. Cosine of 2x will be cosine squared of x minus sine squared of x. And cosine 2x will be 2 cosine squared of x minus 1, or 1 minus 2 sine squared of x. Tangent of double angle will be tan of 2x, 2 tan x divided by 1 minus tan squared of x. So if we have tan x, we can use this formula to find tan of 2x. Also, if we have sine of the double angle, cosine of the double angle, just divide sine 2 theta by cosine 2 theta, we get tan 2 theta. Let's go now to cosine of double angle. Now this is cosine of 2x. We can write it as cosine x plus x. From lecture 21, we can say cosine of x minus sine of x sine of x. So this will be squared minus sine squared of x. So this is formula number 2 here. You see there. Now we know sine squared of x plus cosine squared of x is equal to 1. So I can solve for sine squared one time. I can solve also for cosine squared another time. So I will start here from 2. See, this is 2 cosine squared of x minus sine squared of x. I will get sine squared here from this formula. It will be 1 minus cosine squared. When you simplify this, you get 2 cosine squared of x minus 1, which is formula number 3. Or I can replace cosine squared of x by 1 minus sine squared of x. So when you simplify this, you get 1 minus 2 sine squared of x. That's formula number 4. Now you might ask, which one is the best formula to use, 2, 3, or 4? All of them will give you cosine of 2x. The answer, it depends on the given. If in the given you have sine of x, use this 4. If in the given you have cosine of x, use number 3. But you can use any one. All right, the other double angle formulas, suppose we need, in number 6 here, suppose we need cosecant of 2x. Just directly use the reciprocal, 1 over sine 2x, and use this formula number 1. If you need to find secant of 2x, just 1 over cosine of 2x. Remember, in the cosine of 2x, there are 3 formulas to use. I put here only one of them. If you need cotan of 2x, reciprocal, 1 over tan of 2x. We know tan of 2x. See the formula number 5 there, formula number 5. And then take the reciprocal, it will be 1 minus tan squared of x divided by 2 tan x. Let's start with examples. Number 1 is very important. Why it's very important? It covers the ideas in this lecture directly. So we have cosine of the A. A is an angle between 3 pi over 2 and 2 pi, which is quadrant 4. Cosine of A is 3 over 5. Let's find three things here. Sine of 2a plus cosine of 2a. You have to find each one separate, then add. Cotan of 2a. In this one, you need the reciprocal of tan 2a. And here we have to find secant of 2a plus tan of 2a. Let's start with the first one. We have cosine of a 3 over 5, which is x over r. As I mentioned, from the given a is in quadrant 4, so in quadrant 4, for sure, we have to find a y is negative. So x squared plus y squared is equal r squared. See, this is the x here, 9, y squared we have to find 25. So y squared will be 16, y will be plus or minus 4. Why we choose the minus? Because a is in quadrant 4. So now sine of a minus 4 over 5, which is by the formula y over r. So from cosine of a, we found sine of a. Let's find the first part here, sine of 2a, by the formula number 1. 2 times sine of the a, cosine of the a. Just multiply 2 times minus 4 over 5 times 3 over 5. You get this answer minus 24 over 25. Now let's find cosine 2a, where we have 3 formulas, and then you can add these two values. Let me mention here, we have cosine of a given, so it's better to use this formula for cosine of 2a, 2 cosine squared of a minus 1, because 3 over 5 already given. It's easier to use the given. So this is 2 times this squared. See, this squared becomes 9 over 25 times 2, that's 18 over 25 minus 1. That's the answer. Now you can add, this is part 1 now, sine of 2a plus cosine of 2a, it will be minus 31 over 25. Now here we have to find in part 2 cotan of 2a. Cotan of 2a, it will be the reciprocal of tan of 2a. So let's find tan of 2a. Tan of 2a is 2 tan a divided by 1 minus tan squared of a. From part 1, I can say tan of a will be y over x, which is minus 4 over 3. See, given in the question cosine of a, I found already sine of a. I can divide sine of a over cosine of a, or directly I can find tan of a y over x. You get the same answer. So this is the tan now, minus 4 over 3. Just put that in the formula here. 2 times that, 1 minus the same number, minus 4 over 3 squared. So multiply here, minus 8 over 3. Square this one, 16 over 9. Simplify these fractions, you will get, please try it. You will get 24 over 7. So cotan of 2a, the reciprocal of that, 1 over tan 2a. Don't forget to do that. 1 over that, so it will be cotan of 2a, 7 over 24. Now in the last part, we need secant of 2a and we need tan of 2a we have found already. See tan of 2a here, 24 over 7. We need secant of 2a. Secant of 2a is the reciprocal of the cosine, and we have already found cosine of 2a, so it will be minus 25 over 7. So I can add now secant of 2a minus 25 over 7 plus 24 over 7 will be minus 1 over 7. This is a medium question here. 4 cosine squared of 10 theta minus 4 sine squared of 10 theta. That's an expression equals k cosine t theta. We have to find the value of k, value of t, and then we add them. So we have to look here on the left side and see which formula is similar to that. So let's rewrite the expression on the left using this formula. See, on the left we can see cosine squared of something, you see, minus sine squared of something. We know that formula here. Cosine squared of the x. X is any angle there, minus sine squared of the x. If you go back It will be cosine of the double angle. See, take 4 here, common factor. That's the given now. 4 common factor. Inside the bracket, we have cosine squared of 10 theta minus sine squared of 10 theta. Now let's go back. See the 10 theta here in our question, the 10 theta is the x. See, x and x. So it will be 4 outside. By this formula, it will be cosine 2 times the x. And remember here, the x is the 10 theta. So it will be, this is k cosine t theta. So from the last slide, we can see 4 cosine 2 times 10 theta will be 20 theta is equal to k cosine t theta. So k will be the 4 and the t will be 20. When you add k plus t, it's 24. Question number 3 is not easy because we have to derive a formula for sine of 3x in terms of sine x. So we start by sine of 3x. We can write it as sine of 2x plus x. See, we have to derive the formula. Just remember from lecture 21, sine of the sum, sine of u plus v will be sine of u cosine of v plus cosine of u sine of v. We have seen that before. So now the u, let's take it as 2x and v is x because 2x plus x is 3x. Just apply this formula here. Sine of 2x times cosine of the x plus cosine of 2x sine of x. This one we have a formula for double angle, sine of double angle, formula number 1, 2 sine of x cosine of x. You can go slowly here and compare. So this is cosine of x, we write it. Cosine of 2x, we have 3 formulas. Why I have chosen this? 1 minus 2 sine squared of x, because I need all the answer in terms of sine of x. And there is a sign here at the end. Now let's multiply here 2 sine of x. This is cosine of x, cosine of x becomes squared. And here we distribute sine of x minus 2 sine cubed. This one we can leave it. This one we can leave it. This one we can leave it. The only thing we have to change is cosine squared of x. Now cosine squared of x, there's a formula 1 minus sine squared of x. Replace it there here. And then distribute 2 sine x minus 2 sine cubed. And we have already there sine of x minus 2 sine cubed of x. Let's add and combine like terms. So 2 sine of x becomes 3. And this is minus 2 becomes minus 4 sine cubed. That's the formula and the answer. Lowering powers formula. We know cosine of 2x, 1 minus 2 sine squared of x. Let's solve for sine squared from here. See, take this on the other side and bring cosine of 2x on this side. And then divide by 2. So you get LP1. This is lowering powers 1. Sine squared, if you have something squared on the sign, you can replace it 1 minus cosine of 2x divided by 2. See, the power here on the cosine is 1, but the angle is doubled. Be careful here. Squared on the sine, power 1 on the cosine. Here we have x, and here we have 2x. So when you replace sine squared, you can write instead of that 1 minus cosine 2x divided by 2. Same thing for cosine squared of x. We can get that from this formula. So we will say 1 plus cosine of 2x divided by 2. We will call this LP2. Now LP3, just divide LP1 over LP2 because we know sine squared of x divided by, you see that here? Divided by cosine squared of x will give you tan squared of x. So tan squared of x will be 1 minus cosine 2x divided by 1 plus cosine 2x. This is LP3. So these are nice formulas. We will use them to derive half-angle formulas in lecture number 24, the one after this. Let's see, very good example, really. Let's express sine squared of x times cosine squared of x as a plus b cosine cx. So first you write all this product as this form. After you finish, you get a multiplied by b multiplied by c. We need this value, which is a number. So for sure, when we see squared on the sine, squared on the cosine, we can think directly of this, LP1, LP2. Now for the solution of example 4, directly we replace sine squared of x using LP1, 1 minus cosine 2x over 2, cosine squared of x, this is LP2, replace it by 1 plus cosine 2x over 2. I have put the formulas here just to use them there. Now multiply these as fractions. Multiply 2 times 2 is 4. This is a difference between two squares. You can use the algebra stuff. 1 minus cosine squared. Now let's split this one as, just be careful here, 1 over 4 minus 1 over 4 cosine squared of 2x. Why I did that? Because I need to use the LP2 again. See, this is squared on the cosine, but the angle is 2x. So according to LP2, this angle here will be doubled. So that will be 1 plus cosine of 4x divided by 2. I will say it one more time. Cosine squared of x becomes 2x. If we have cosine squared of 2x, that's what we need to replace. 1 plus cosine, double angle of that. 2 times 2x becomes 4x. Divide by 2. Now you need just to simplify the fractions here. Multiply 1 over 4 times that, or you can split this and then multiply. It's up to you. So what I did here inside, I split 1 over 2 plus cosine 4x over 2. Then I multiply. You can multiply from the beginning if you like. So that's 1 over 4 minus 1 over 8 minus 1 over 8 times cosine of 4x. So this one you can add 1 over 4 minus 1 over 8. LCD is 8. So here A is 1 over 8, the first number. You see, this is the required form. So that's A. B is minus 1 over 8. C is 4. When you multiply everything, you get minus 1 over 16. So this is lecture 23, double angle formulas. Now, the lecture after that will be lecture 24 about half angle formulas. So you can find, please, some old exams questions to practice on both lectures at the end of the next lecture. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture number 23. And I hope I can see you in another video with another topic. Thank you very much.